The giant machine that detected gravitational waves and confirmed a prediction of Einstein, that was a century old, it's called LIGO, Laser Interferometer Gravitational Wave Observatory. It should have been called, just if you're following those letters, LIFGWO, like John Lithgow. And you'd be able to detect gravitational waves further than a rock is from the sun, the third one. Yes, John Lithgow reference. It's you usually don't get to make that machine, LIGO, that detected those gravitational waves. There's two of them, and they each kind of look like a giant L, and each tube of this L was 4 kilometers long, and combined it made for the second largest vacuum on Earth, second largest volume of almost completely empty space on Earth. It was actually like bringing space down to Earth. How they accomplished this was pumping out all of the air for 1,010 hours, such that the tubes got down to 1/1,000,000th of an atmosphere. So some of the biggest nothings on Earth found some of the biggest somethings in scientific history and recent memory. LIFGWO? More like LIFGWOW. Hello, and welcome to another episode of Because Science Footnotes, the companion show to Because Science, where I take all your comments, questions, and corrections and say things before and after them, and then I also tell you what's coming up next on this channel. Hint, it's very, very quiet. It's so quiet. Oh. It's gonna be quiet. Oh, shh. Shh, 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 shh. It's okay. Daddy's got you. Put your headphones back on. Listen to me. So on the last episode of Because Science, I was arguing why Ant-Man may in fact be the most powerful Avenger of all. If Scott Lang really could harness the powers of the quantum realm, then I said he could harness all of the quantum weirdness that comes along with quantum mechanics. Then he could do the reality-bending kinds of things that particles at the quantum level can do, like jumping among different world lines and picking and choosing when and where it wants to exist and how. And then he could possibly change the future of the MCU. Or not. That's just a theory. A theory I have. But what did you have to say? But what did you have to say?
But what did you... Oh, yeah. But what did you have to say?
But what? But what? Center yourself. Hey, but what did you have to say? Let me rap with you for a second. Turns chair around backwards. Our first comment comes from Super Nerd Giggity Guy, who says Ant-Man also probably has a slightly less powerful but more understandable ability. And Giggity Guy goes on to say that because electrons can get closer to their nuclei in atoms, which would shrink the atom, which is what Ant-Man might be doing, when they get closer to their nuclei, they emit energy in the form of photons, and photons sometimes of visible light, but it'd be light across the spectrum. Then when Ant-Man or the Wasp shrunk down, they might have to emit a burst of light, which would make them like the brightest neon sign in the universe, possibly blinding or possibly frying everyone in the immediate vicinity with huge amounts of heat and light, which I'll admit, would be pretty dope. So the main way Ant-Man is supposed to shrink down is by reducing the space between his atoms. So electrons orbit nuclei of atoms, and electrons repel each other because they have a similar charge, and that's what keeps atoms from crossing over each other and getting too close. Now, what Pym particles might do is decrease... Come here. Ow! Is decrease the distance those electrons orbit their nuclei, and then the atoms can get closer together, which would shrink the entire object. I'm not sure what exactly Pym particles do, no one is, but if they were reducing the energy states and forcing electrons to jump to lower levels of excitation around their nuclei, then maybe they would get a little bit closer together, and then maybe they would also emit ultraviolet light in all directions when Ant-Man or the Wasp shrunk down, and then everyone would get a gigantic sunburn. Maybe. As we'll get to, the physics of Ant-Man are inconsistent. Snap together, you're not even an accurate representation of a molecule. I'm fine. Our next comment comes from Nomada Lunar, someone who lives on the moon by themselves and moves around. Says, is Kyle secretly Thor's brother? No, but I was at an event once that Chris Hemsworth was at, and a little girl came up to me and said, are you Chris Hemsworth's brother? Can you help me meet him? And we were both disappointed because no, of course not. If I could help you meet him, I would have met him first. I would just do it out of the kindness of my heart. Let me get it. Cut to picture of me with Chris Hemsworth, but he's looking off in a different direction. That was a weird night. Chris Hemsworth in a crowd full of people is like a bar magnet surrounded by iron filings. The closer that you are to Chris Hemsworth in a room, the more facing him you are, and as you get further away, you're facing him less, but everyone is still facing him. So in this room with Chris Hemsworth in it, everyone at the edge, there's 200 people in the room. Everyone on the edge of the room isn't totally facing him, but they're all like just looking. And then everyone, as you get closer and closer and closer to him until you're right there, and then people right next to Chris were just like, hey, I really love your, I'm fine. I almost passed out and threw up. Our next comment comes from Mexgar, who says, I mean, technically the Wasp would also be the most powerful Avenger since she has the exact same power set. Yep. Yeah, Ant-Man's powers don't come from his own self intrinsically, they come from his suit. So the Wasp would be, yes, just as powerful unless something happens to her. Go watch the movie. Also, if I had to choose between fighting an ant or a wasp, you do not want to fight a wasp. They are terrible, wonderful, scary, beautiful creatures. Wasps, parasitoid wasps, scientists now think, wasps that parasitically infect other organisms and that infection kills them, like laying a baby wasp in something's abdomen and having it eat its way out while the thing is still alive. Parasitoid wasps are now thought to be possibly the most diverse animals on the planet. More parasitoid wasp species than anything else species. And if that doesn't freak you out a little bit, Google emerald cockroach wasp. And then come back to me. I'll wait. Oh, hey, you back? Yeah. Brain surgery, coffins, chest bursting. It's all there. But they're pretty. Our next comment comes from Nin10, who says, Batman is the most powerful Avenger as he takes us on field trips on the Magic Millennium Enterprise to Prehistoric Park while hiding his secret identity as Isaac DeGrasse Einstein, the science boy. What did I just read? Let's get back on track. Our next comment comes from Sean Heath, who says, why would being supersized make you move in slow motion? I think this is an actual illusion. Not like, like my hair implies, like I'm a magician, but like a motion illusion. So when things get bigger or smaller, to move at the same velocity, whatever is moving them would have to change speed. So say Ant-Man made a van that he was in really small. If the van was traveling, I don't know, 50 kilometers an hour, when it got really small, if it was still going 50 kilometers an hour, the wheels are the things that are covering that distance. So because the wheels get smaller, how much they rotate would have to go way up. Their RPM would have to go way up because the surface of the tires, it's not as long. So it'd have to cover more distance in the same amount of time, and the RPM would have to go up if it kept the same velocity. Similarly, if you went to giant man size and you were walking at X velocity, your legs would have to slow down because to cover the same distance in the same amount of time, each stride is covering more distance. So you don't have to have the same quickness in your stride. You can go slower looking while going the same speed. So even though it looks like Ant-Man when he's Giant Man or other giants or titans or whatever are moving in slow motion, they're actually moving the same speed, if not a lot faster. So it's not a, "Hava, was this your card?" illusion. It's more of a, oh, math. Not nearly as, see, nothing up my sleeves. Except regret. Our next comment comes from Blake Neal, who says, I'm having a hard time not cringing when he says temporal like that. It's pronounced temporal, is a schwa, not temporal. A lot of people have problems, apparently, with my pronunciation of things, like temperature and temporal. What do they want me to, temperature and temporal. Oh, that's not so hard. I'm sorry. Still not gonna do it though. It's ingrained in me. It's just how I do things. Watch how I write lowercase a's. It's weird. The way we learn to do things, it's just easier to continue to do things the exact same way. We kind of ingrain our habits and our tastes and our likes. Why do you think that you love the music the most that you loved when you were a teenager? That's when you were forming and all of your hormones and all your changes, all these things were coming together to form your likes and your interests, and so now you still love Nirvana. Similarly, in between that time range is a temporal thing. But the nerdiest comment at the time I'm filming this episode I am giving to this person's name. Someone could tell me how to pronounce that? Great. Who says, emoji Ant-Man must be blind when he shrink down to the size of subatomic particles because his eyes can't perceive any photons. This is the nerdiest comment this week because it made me think about a bunch of other stuff. Human eyes can actually detect single photons of light. And this is going to be important for an episode that will be coming up on this channel very soon. Human eyes are actually incredibly sensitive. So it's not that Ant-Man wouldn't be able to detect any photons of light at that size, but the size of the eye, or whatever you're detecting light with, matters quite a bit. The size of your pupils affects how light enters those pupils and what kind of patterns the light makes when it hits the back of your eye. And therefore your eye is limited by how light diffracts as it goes through the aperture of your eye. And if you get really small, the pupil size gets really small, and your angular resolution, again, we will go through this in a future episode, your angular resolution gets a lot worse. So if Ant-Man was to shrink down to the size of an ant, his eyesight would be terrible. It wouldn't be gone, but it would be blurry and not very effective. This little consequence of physics probably contributes to the reason why insects, like ants, have compound eyes. They don't have lenses like we do, so that they can resolve images and movement in different ways that takes advantage of how small their eyes are. Lenses only work above a certain size, and so ants have different eyes because if you were to get to the size of ants, our human eyes wouldn't work. And I learned all of that from your comment. So congratulations! You are a super nerd. Ah! Is this your super nerd? Why are they always out of breath? They're not doing that much. Oh, I sawed a woman in half. Sawing a woman in half, if you actually did it, would be pretty hard. Skin is tough, and our ligaments. Depends on the sharpness of the... We shouldn't go into this. But of course, I'm not always right. I was wrong about a couple of things in this episode, legitimately. So let's get right down to it. Our first correction comes from Kerr and super nerd Toby Toastbrat and Jeff Goldbroom, who all say something about, well, at some point, wouldn't Ant-Man, if he was shrinking down to quantum level stuff, wouldn't he turn into a black hole? All right, I see this Ant-Man black hole thing in a ton of videos and comments, especially other channels that have a lot of subscribers also make this argument, but it's not true. Yes, at some radius, if Ant-Man was like a sphere, he would turn into a black hole. But the radius at which quantum effects would start to take over are much, much, much greater than this radius. So what everyone is describing is the Schwarzschild radius. Maybe I pronounced that correctly. I mean, the time between when I did that and pronounced it correctly is a temporal thing, but. So the Schwarzschild radius is the radius at which, if you condense some mass down into a point source, that it would collapse on itself and form a black hole. Now, if we take the mass of Ant-Man per wikias and such and plug that into, let's say, wolframalpha.com, you get a radius to form a black hole, if you were Ant-Man, of 10 to the negative 26 meters. Now, for context, a proton is 10 to the negative 15 meters. So trillions of times bigger. So if Ant-Man can get down to the size of protons, he doesn't even have to worry about getting to the size where he would become a black hole. So the black hole problem isn't really a problem because in all of the circumstances where we've seen Ant-Man shrink down, he never gets quite that small. So to form a black hole, Ant-Man would have to go subatomic, which we don't see him do, and he doesn't need to do. And as we will get to in a correction coming up, he can't do. So it's double or triple not a problem. Our next correction comes from Joshua Hillerup and Aaron Bagel, who say something like, even if Ant-Man is reducing the distance between his atoms, he still has all those atoms, and like I said, they would still have all of those weird conflicting paths, right, to their wave functions, and they would all cancel out, so there wouldn't be any quantum effects, right? Well, very basically, why our human-sized bodies don't experience quantum effects is, like I said in the episode, we are too big. We have too much mass, and we don't go very fast. And like these corrections point out, if Ant-Man's mass is staying the same, even though he doesn't fall through floors and stuff, then why would the wave function change? Why would he suddenly start experiencing quantum effects if we don't? Well, you're right. He wouldn't. So what I left unsaid and what the movie leaves unsaid, because it's very inconsistent with all of its physics, is that maybe PIM particles can make the user coherent, all of the particles acting in the same orientation, in the same phase, so that it can operate like a quantum system. So it could, let's say, quantum tunnel through an object like we see Ghost do in the trailers and the movie, the main villain. So the quantum effects wouldn't necessarily have anything to do with the size of Ant-Man or the mass of Ant-Man, which brings us into our next correction. The best correction at the time I'm filming this episode, I'm giving to Emmett is Random, M. Walsher, and Once Upon a Dash Cam, but I'm highlighting those, but other people also made this comment, who say something like, how could Ant-Man go subatomic? He is still made out of atoms, so the smallest he could get is if all of those atoms were just touching each other. And necessarily, a cluster of atoms couldn't be smaller than one atom. So how could Ant-Man go subatomic like the movies say, and like I said in my episode, at all? Well, to put it bluntly, you are correct. You cannot go subatomic. Even if I removed all of the space between the electrons and your nuclei, just put all of your atoms as close as they could get together before they form something like a black hole, you would still be larger than the smallest atom, and you wouldn't be able to go subatomic. So what's going on here? Well, the movie is just mentioning subatomic, and I said it in my episode because I'm trying to speak the movie's language and the universe of Ant-Man, that language. But Ant-Man wouldn't actually be able to go subatomic. Quantum effects don't actually depend on how small you get. It's a common misconception, and I feel bad presenting that common misconception to you because it's a misconception that I also had. You don't have to go really small to experience quantum effects. You just need to to tap into the quantum world in such a way that you are, like I said, coherent, so that all of your atoms could act like a quantum system. I actually spoke to the science advisor on Ant-Man and Ant-Man and the Wasp, and he said if he had a choice, he wouldn't have said go subatomic at all. He would have said go quantum. He told me it's a matter of turning off your entanglement with the rest of the universe so that you can do the weird things that we mentioned in the episode, like choose a different world line for yourself and phase through objects like we see Ghost do. So the shrinking and enlargening is actually a different aspect of Ant-Man's powers. The quantum could be something totally separate, which I think is just as interesting, but you are correct in your correction. Ant-Man wouldn't be able to go subatomic because all of your atoms squished together are still bigger than a single atom. I think it's just easier to present to a general audience. You're like, if you go really small, then weird things will happen at the smallest scales. And we know quantum mechanics does that, and quantum things are small, so if Ant-Man is small, he must have weird things as well about his body. But then you have to make yourself a quantum object somehow. Pym particles. It's like Marvel's Speed Force. It can do anything for you. So to do all the things that I said Ant-Man could possibly do in the episode, he would have to go quantum, like we said, but not necessarily shrink down to subatomic because he wouldn't be able to. So we're half right. Still, maybe. So congratulations, you three. You are indeed super nerds. Now, if you are subscribed to Alpha at projectalpha.com, you already know what the next episode of Because Science is going to be, because you have already seen it along with other premium content like natural selection and stuff from our pals at Geek and Sundry, etc. But if you have not subscribed to Alpha just yet, the next episode of Because Science is going to be very, very quiet, because I'm going to bring you to one of the quietest places on Earth. So quiet. That's right, in this week's episode of Because Science, I'm bringing you to literally one of the quietest places on Earth to see just how quiet possibly gets if you were, say, hiding from aliens that hunted using sound alone. And I got to do this thanks to the film, a very cool film that you should see. It's one of the best films of the year. It's really cool. A Quiet Place, starring Jim Halpert. That's my Jim face. John Krasinski. Anyway, it's a cool movie, cool episode. We went on location again, so I hope you enjoy it. And make sure to put your headphones on and turn them up real loud so that you can hear me. I'm like a human soundboard. So go watch the latest episode of Because Science if you haven't yet, all about Ant-Man and quantum mechanics, and send me your best comments, corrections, and weird questions to youtube.com/becausescience, facebook.com/becausescience, and at Because Science on Instagram and Twitter, because that's where I will go to pull all that stuff for this show. Footnotes. Do it. Do it. And don't forget, you don't have to be just one thing. You don't have to be just an extrovert or just an introvert. Oh, I always have to go out. Or, oh, because I'm introverted, I can never be in a social situation ever. Yes, there are extreme versions, but you could also be an ambivert with mixtures of personality traits from both, which is to say that everyone is on a spectrum of everything. You are so much more interesting than an A or a B or a C or a 1 or a 0. You are a gradient of human. There's infinite possibilities to who you are and what you can do and what you can be. You don't just have to be one thing. Don't hide behind it. Embrace it. Now, if you excuse me, I have a couch with some cats that I need to sit on forever. Bye.